Hello, ladies and gentlemen. Welcome back. We are going to be working on Chapter 6, which is dealing with probability and simulation, the study of randomness. It is an exciting chapter. There are 3 sections in this chapter, so we will be taking a little bit longer on each part. So we can see that in this chapter, we have the probability and simulation, the study of randomness, is chapter 6. So we have, ladies and gentlemen, 6.1, which is simulation. We're going to be taking 2 days to do that. Chapter 6.2, probability models. We're going to take a day and a half with that. And 6.3, we're going to take a day and a half on that. So this lesson, ladies and gentlemen, is going to go 1, 2, 3, 4, 5 days. So 5 days on this lesson. Before we begin, I do want to pull in Schoology really quick. I do want to point out, so right now you're watching this video right here, okay? I want to point out that right above this video, there's a random digit table, okay? If you can run that off, if you have a printer at home, run that off, or use the one in the back of the book. But sometimes it's nice to write on that random digit table, so you may want to have a copy of it in front of you. The examples that I'm going to go over today, okay, are on the simulating experiments. You could print that off too. There are actually 8 problems or 8 examples. I'm going to do 4 in this lesson, and I'm going to do 4 in the next lesson because we're going to spend 2 days on chapter 6.1. Underneath, here are some recommended videos from the College Board dealing with what we're doing today. But what I would advise you to do right now is stop this video and go and watch this against all odds video first. If we were in class, this is the first thing that I would be doing as an intro. So if you haven't watched this, I want you to stop now. I want you to go watch that. Take Cornell notes and answer some questions, and then come back and watch me. All right, so I expect you to pause or stop and go watch that one. All right, now that you are back, ladies and gentlemen, so our next lesson, again, will be simulating some more. And then, but before you watch that video, there are going to be 2 more against all odd videos to watch. I would like you to watch that before the next video of me, okay? So please go ahead and do that. Okay, the book assignments are up and rolling, and all of the links are ready for you. All right, ladies and gentlemen, let's go ahead and get moving on this because it's going to take a little bit of time. So we are going to go to our experimental simulating experiments. So here are the first 4 examples. We're going to be tossing a coin. We're going to simulate tossing a coin 10 times. What is the likelihood of a run of 3 or more consecutive heads or tails? A basketball player makes 70% of her free throws in a long season. In a tournament game, she shoots 5 free throws. What is the likelihood that the player will miss 3 or more? A couple plans to have children. Now, a couple of these are examples from your book. Again, read your book, especially the examples. Okay, so I'm going to do 2 of the examples that are in your book. That's the first one and third one. There are others in there you need to read and go through it. Remember, I do expect you to read your book. It's like a college course. The professor expects you to read your book. All right. A couple plans to have children until they have a girl or until they have 4 children, whichever comes first. What is the probability they will have a girl? A man has 10 ties and chooses a tie at random to wear to work each day. What is the probability that he wears the same tie more than once in a 5-day week? Again, remember, ladies and gentlemen, you have the power of pause and rewind. If I go too fast, pause, rewind, whatever you need to do. All right. These examples are just some of what we are going to simulate over the next several weeks, okay? Because we're going to be taking a little bit longer in this chapter. It is 3 sections instead of just 2 sections, and we really got to get this probability stuff down. Okay, we will develop a probability model and use it to calculate a theoretical answer. This requires that we know something about the rules of probability. That's why if you haven't watched that first video against all odds, I want you to go watch that. Simulation. The imitation of chance behavior based on a model that accurately reflects the experiment under consideration. Simulation basics. Simulation is an effective tool for finding the likelihood of complex results, because sometimes it's just not reasonable, ladies and gentlemen, to go out and figure out something that's actually happening. Okay, like the number of children, or the girls, that third one. Okay, it's not practical to go and interview all these families and see what the theoretical would be. Simulation is much more effective, okay, as long as we have a trustworthy model. That's going to be really important, okay, and that's why we're going to have some steps we got to go through. And yes, you have to follow these steps. So when you run into a problem like this, I'm going to expect you to lay it out just like I am, all right? In particular, we can use random digits from a table, graphing calculator, or computer software to simulate many repetitions quickly. The proportion of repetitions on which a result occurs will eventually be close to its true likelihood. So simulation can give good estimates of probabilities. All right, now this first one, toss a coin 10 times. Okay, tossing a coin, that's not so bad, but I'm to pull out a coin here. That's going to take a long time. Toss a coin 10 times, record it, toss a coin 10. Okay. It's much quicker to simulate it with a random digit table. All right, so we're going to see what is the likelihood of a run of 3 or more consecutive heads or tails. Now, here are the steps. All right, step number 1. We are going to state the problem or describe the random phenomenon. Basically, ladies and gentlemen, that's like just restating the problem, okay? State the problem or describe the random phenomenon, one or the other. For this one, I'm just going to restate the problem. So, toss a coin 10 times. What is the likelihood? You're going, really? You have to do this? Yes, you do. Of a run of 3 or more. If I spell something wrong, please forgive me. Consecutive heads or tails. All right, there's step 1. Boom. Ooh, step 2. Okay, assumptions, folks, assumptions. Well, we have to assume that heads or tails is equally likely to occur on each toss. In other words, 50-50. There's 2 assumptions. There's always 2 assumptions. The one assumption is on the likelihood or the probability, okay? Heads or tails is equally likely to occur on each toss, 50-50. But we're going to be using random digits, right? So what we're going to do to keep this 50-50, we're going to say odd digits. Oops, I'm sorry, I'm in the wrong spot. That's step 3. We're going to say toss or tosses are independent, okay, of each other. In other words, what happens on one toss will not influence the next toss. Okay, so those are the 2 assumptions. The probabilities have to be equally likely, or not in this case, they have to be equally likely. It'll change when we get to the other scenarios. And things have to be independent of each other. All right, let's keep rolling. Step 3. Assign digits to represent outcomes. Okay, so this is where we're going to say that one digit simulates one toss of the coin. Again, if I'm going too fast, pause and rewind. Okay, that's one thing. One digit simulates the toss of a coin. Odd digits represent heads. Even digits plus 0, okay, because 0 is technically neither positive or negative. Even digits plus 0 represent tails. Okay, so odd digits. So I'm gonna go ahead. So 1, 3, 5, 7, 9. Okay, odd digits. Even digits plus 0. So I'm going to go ahead and go, okay, 0, 2, 4, 6, 8. So there's 5 of each. So they're equally likely, right? So 5 of each. So that is assign the digits. Be specific. Simulate many repetitions. Okay, so what we're going to have to do, ladies and gentlemen, is we're going to have to look at 10 consecutive digits which simulates one repetition. Ten digits, that's one repetition. Now, we're going to, in this problem, we're going to start at line 101 and do 25 repetitions. You're going, what? 25? That's the standard amount to do is 25 to 30. Sometimes I'm just going to have you do 10, okay? Because once you get the idea. But if this was the AP test, you would want to say, yeah, we're going to do about 25, 30 repetitions. I think on the AP test, though, if they've had students do some of this, they actually tell you how many repetitions because they want to get this. They want all students to get the same answer. Okay, so we're going to start at line 101 and we're going to do 25 repetitions for this one. Now, if we look at line 101. All right, so let's see if I can get this to work. So we've got here, this represents the first 10 tosses. Okay, and then this represents the next 10. So that's 2 repetitions, there's 3, there's 4. And then I'd keep going, 5, 6, 7, 8, 9, 10, and so on. Okay, I'm not going to go through every single one of those repetitions live in this video. Okay, I'm gonna stop and I'm gonna figure out the answer and then I'm gonna just go, okay. So at some point I want you to pause, okay, but not yet. All right. So now let's look at what we're doing here. So what I'm gonna do is I'm gonna type out. So the first 10, just to show you folks, the first 10 is 1, 9, 2, 2, 3, and then 9, 5, 0, 9, 5, 0, 3, 4. Okay, let me double check to make sure I got that right. Yes, I do have that right. Okay, I'm gonna clear this because there we go. So what I'm gonna do, ladies and gentlemen, is I'm gonna look at, so remember, the 1, 3, 5, 7, 9 are heads and the other ones are tails. So what do I have going on here? Okay, let's see if I can do this underneath. Okay, so I have the first one is heads because it's a 1. 9 is heads, and then I've got tails, tails, and then I have heads. Okay, so those are the first 5. Heads, heads, tails, tails, heads. Okay, well then the next 5 give me Heads, heads, tails, heads, tails. So the question is, did I get 3 heads or 3 tails in a row? And yes, I did, ladies and gentlemen, right here. So this is a yes. I got 3 heads and 3 I got 3 heads or 3 tails in a row. So in this first batch, that's a yes. I did get 3 heads or 3 tails in a row. Okay, if I look at the next batch of 10, okay, the next batch, so basically, folks, you just have to look for 3 evens or 3 odds in a row. Now, you always have to do every 10. You can't just do 5. You have to do every 10. So I see, ladies and gentlemen, okay, let me do it like this. Let me back that up a second. So I'm going to do this. These 10 right here. So yes, folks, right here I've got 5, 7, 5. I don't even need to look at the others. This is a yes. Okay, then the next 10. Do I have 5 evens or 5 odds in a row? Heads or tails? So let's see. Yes, I do right here. 6, 4, 0. That's a yes. Okay, and then I keep going in this fashion. Okay, then the next one. 4, 2, 5, 4, oh, right here, 4, 4, 8. That's a yes. All right, so I just did 1, 2, 3, 4 repetitions. If you didn't get that, rewind that part and listen to it again. So I want you to pause right now, and I want you to figure out the rest of them. Okay, I did 5 of them. You've got 20 to go, and see if you get the same result I do. So pause right now, and then come back. All right, so welcome back, folks. Hopefully you did that. So if you kept going in that fashion, ladies and gentlemen, you did 25 repetitions. 24 of them, 24 of the 25, you had 3 heads or 3 tails in a row. There's one in there where it was not. If you didn't get that one, go back and do it again. Now, that's 96%. Now, remember, we write a sentence here, folks. So we are going to say, ladies and gentlemen, we estimate that the probability of getting 3 heads or 3 tails in a row out of 10 consecutive tosses to be about, well, we said estimate already, 96%. That's what our simulation showed us. Okay, we estimate the probability of getting 3 heads or 3 tails in a row out of 10 consecutive tosses, details, to be 96%. All right, let's look at the next one. A basketball player plays 70 or makes 70% of her free throws in a long season. In a tournament game, she shoots 5 free throws. What is the likelihood that the player will miss 3 or more shots? All right, to save a little bit of time, I went ahead and quickly typed out the 4 things. So, step number 1, simulate free throws of a person who shoots 70%. What is the probability she misses 3 or more shots out of 5? Okay, that's the problem. Next, each shot has a 70% chance of being made. Each shot is independent of each other. Conditions. 2. Okay, next, 1 digit simulates a shot at the basket. 0, 1, 2, 3, 4, 5, 6 That's 7 digits, folks. 1, 2, 3, 4, 5. That's 7 digits. Represents making the shot. And then 7, 8, 9 represent missing the shot. Look at 5 consecutive digits, which simulates 5 shots at the basket. Start at line 145 and do 25 repetitions. Okay, so I'm just going to look for 7, 8, and 9, folks. If there are 3 or more, okay, 3 or more 7, 8s, or 9s, so if there's 3 or more of these digits out of the 5, that means that's a yes. She missed 3 or more. All right, so we're going to go to line 145. Okay, here's line 145. So the first 5 digits, I have, remember, 7, 8, and 9 are missing it. So looking at the first 5 digits, I do see a 7, 8, and a 9. So that's a yes, folks. She missed 3 or more. Okay, then I look at the next 5. 1, 2, 6, so that's a no. She did not miss. Sorry, this is really sloppy. I think what I'll do is I'll actually do this. Okay, I'm not going to do all 25. I'm going to pause it again when I get there. But, okay, I'm going to do this. So the first 5, that's a yes, because there's a 7, 8, and a 9 in there. Now remember, it doesn't have to be all 3. It could be, you could have 3 8s in there, and that would be a no. Okay, so the next one, no, she did not miss 3 or more. Okay, the next one, let's see. I see a 7, an 8, and a 7. Well, yeah, 7, 8, 9 is a miss. So that's, yeah, she missed 3 or more again. Okay, I'm going to do one more. So the next one, we've got a 9 and an 8. So nope, she only missed 2. So that's a no. Actually, I'll do one more. Okay, the next one, I see 2 9s in there. That's it, 2 9s. So that's a no. She did not miss 3 or more. So that was 1, 2, 3, 4. That was 5 repetitions. So pause the video and do the other 20. All right, pause it now, please. All right, so hopefully you paused and you found the rest of them, and this is what you actually should end up with. Okay, there is 6 times out of 25. Okay, at least that's what I came up with. 6 out of 25, which is 24%. So our conclusion here, based on our simulation, is that we estimate the probability that she will miss 3 or more shots out of 5 to be 24%. All right, whether that is true or not, okay, that's the only way to get a more accurate answer is to do more repetitions and more repetitions. But again, it goes pretty quick. All right, we're going to do 2 more of these. So I'm going to go to the next one. Okay, I'm going to read it, and then I'm going to pause my recording, and I'm going to get everything set up. A couple plans to have children until they have a girl. Until they have a girl, or until they have 4 children. So they could end up with 4 boys, and then they'd stop. Okay, so whichever comes first. What is the probability they will have a girl? All right, I'm going to go ahead and get this set up. Be right back. Okay, so now on this one, ladies and gentlemen, well, I'll get to it. All right, so 1, simulate a couple having children until they have a girl or until they have 4 children. What is the probability they have a girl? 2, okay, conditions. There is a 50% chance of having a boy and a 50% chance of having a girl. Okay, 50-50. And each child is independent of the next. Those are the conditions. All right. One digit will represent a child. Odds represent boys. Again, you can pick whatever you want. Odds represent boys, and evens plus 0 represents girls. Look at one digit at a time. Ooh, this is different. You got to look at one digit at a time. Stop when you get a girl, which will be even or a 0, or until you have 4 children. Okay, start on line 120 and do 25 repetitions. Okay, so this one's a little different. We don't do a chunk of numbers. We do one number at a time. Okay, I'm going to blow this up a little bit more here. Okay, so line 120, there it is. So here we go. So like, let me make this a little bit thinner. So 120, so we got a boy, boy, girl. Okay, that's a yes. They had a girl. Remember, we're just wanting to know what's the probability of having a girl. So they had 3 kids, they had a girl. Now the next couple, boy, girl. Okay, they had 2 kids, so that's a yes. Okay, the next couple, boy, 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 boy. Ooh, they had 4 kids and no girl, so that's a no. They did not have a girl. The next couple, oop, they had a girl, they're done. They're done. 1 child, girl, that's a yes. Okay, the next couple, boy, boy, girl, that's a yes. Okay, then the next couple, oh, they had a girl, first one, girl, they're done. They're not having any more. Okay, then the next one is boy, boy, oh, nope, girl, boy, girl, so that's a yes. Okay, so do you see how it's working? If not, go back and listen to what I did. So I want you to go ahead until you have a combination of 25 yeses and nos, 25 of them, a total, and then you're done with your simulation. Okay, pause this and finish it. All right, now if I did my math correctly, I got 23 times that they have a girl out of the 25. Okay, hopefully I didn't mess up. So 23 out of 25 times they had a girl, and that's a 92%. All right, so we're going to say we estimate the probability that a couple will have a girl. Let's see. We'll have a girl is 92%. Okay. We estimate the probability that a couple will have a girl is 92%. All right, ladies and gentlemen, one more. And then I'll do 4 more in the next video. A man has 10 ties and chooses a tie at random to wear to work each day. What is the probability that he wears the same tie more than once in a 5-day week? All right, folks, I'm going to go ahead and I'm going to pause my recording and I'm going to get this stuff set up. So here we go. So 1, simulate picking out a tie randomly each day. What is the probability that a tie will be picked more than once in a 5-day week? So sorry about that. Let me fix that. All right, 2, there is a 10% chance of picking the same tie. Each tie is independent of the other tie. 3, one digit represents a tie. Each digit represents a different tie. 4, Look at 5 consecutive digits when simulating a 5-day week. Seed the calculator with the number 300. Okay, so we're going to use the calculator this time. All right, so this is how we do it. Here we go. Again, rewind if you don't catch it the first time. So on our calculator, we're going to go ahead and type in 300. Hit the store button. That's above the on button. Then go to math. Then go to probability, PRB, and pick number 1, rand. So what we're doing is we're seeding the calculator so you're all going to get the same answer. Okay, we're going to hit enter. Okay. One thing, did I say how many repetitions I'm going to do? I'm going to do 25 repetitions. So I'm going to add that to this real quick. Okay. All right, so back to the calculator. All right, so I've seeded the calculator. Now what I'm going to do, I'm just going to clear my screen. I'm going to go back to math. I'm going to go back to probability, and I'm going to pick number 5. Now, this is the nice thing. What I'm going to do is I'm going to go ahead and I'm just going to use 0 through 9. 0 through 9. Okay, because I said digit. So I'm going to go 0, comma, 9. So the calculator is going to randomly pick 0 through 9. And then I'm going to put a comma, and I'm going to put a 5 for a 5-day week. Okay? If you didn't get that, rewind it and listen to it again. So here's the first week. That's a yes. 2 ties. He wore 2 ties twice. So that's a yes. Okay? Now, all you have to do is hit enter. There's the next one. So that one is a no. Just hit enter. Okay, let's see. That one is a no. Okay, hit enter again. Okay, oh yeah, he wore 1 tie 3 times and 1 tie twice. So that one's a yes. Okay, hit enter. That's a no. He did not wear one of his ties twice. Okay, so I did 5 repetitions. I'm going to pause and finish this, and then I want you to pause and finish it, and then I'll be back with my results. Hopefully yours match. All right. Hi, so hopefully I didn't mess up. Okay, there's always that possibility, folks, so hopefully I didn't. This is what I came up with for the conclusion. Okay, I came up with 15 times out of 25 he wore the same tie more than once, okay, which I got as 60%. So we estimate the probability of wearing a tie more than once a week to be 60%. Voila. I like using the calculator a little bit better because then, you know, you're not, I don't know. I like using the calculator better, but you have to be prepared to do either way, either with the random digit table or with the calculator. Okay, I'm going to do in the next lesson, I'm going to do 4 more examples of this. So hopefully you'll understand how simulation works and how to set it up. Remember, there's 5 steps. Okay, I didn't put 5 on that last part, but that's step 5. Okay, so follow those steps whenever doing a simulation. All right, see you soon, folks.